So I'll get us started. Yeah, so awesome to see everyone. It's great to see familiar faces and see some new faces, and we're just super excited that we're setting sail and that we've sort of made it to this point in the process. So our flagship is called Networks for Hazard Preparedness and Response. We have a whole collection of partners today. Christine, Harry, and Leave are going to talk a little bit from the partner perspective. But we also work with quite a few others. And then I think one of our key points here today is we would like to work with even more. So I hope those of you who are interested but not yet involved with this work have the opportunity to do so. I'll pause. Paula, do you want to?
So what we really want to talk about is this idea that is captured in the diagram on the right. So you can see multiplex, right? Various layers that interact during hazards. And so what we really want to think about is hazards. We're going to start with flooding, but then we'll get to other hazards as well in the later parts of this project. But you got to think about that during an event, like a flood event, is not only the rivers that are flooding, but it's also the roads that are impacted and terrain depressions where water is being held. And you have people on top of this and emergency responders and so forth. So our goal is really to come up with rigorous research that can use novel network approaches that are capable of having all these layers interact during events and really be able to capture their exchange of information, their dynamics during events, so that we can be better prepared, predict, of course, these events ahead of time, and also have a better response. And then in the second part, what we want to do, so we will be working with a couple of study areas, and that's going to be Southeast Texas and the city of Austin. And then from there, we wanted to expand in the later part of the project to other hazards across Texas and possibly across other parts of the, not only the state. I think that the beauty of this approach is that it's a mathematical approach. And so once you construct it, it becomes a workflow that can be applied elsewhere. Next slide, please. So we want to start with flooding, and all of you have experienced big floods here. Actually, Texas and Austin in particular is a very interesting place to do hydrology because you experience not only droughts, but also very extreme flash floods events. And Southeast Texas, our other area, is also very exposed to flooding, right? And so what we need to be aware of is the fact that in urban areas, normally there's flood mapping information, but lots of areas are not covered. And even those areas that have mapping information, actually those maps need to be updated because as the record extends and the record is changing, we actually started realizing that those maps may not be as accurate. Next slide, please. And so what we wanted to think about is approaches to do flood inundation for emergency responders. So when you think about flood inundation mapping, there's various ways of doing this. Modeling on one side, you can think about very complex models as well. They may take more time to run. As computing resources improve, this is going to be less of an issue. But what we really wanted to have is something that can give you flood maps within seconds. All right, so something really quick. And so you need a forecast of flows that comes, in our case, from a continental scale model that is run out of NOAA and others from the National Water Model. You need terrain information, so topography. You need information on the river network, and you need an approach for mapping. And really our goal, as I said, is to have something that is simple, that is fast, and is co-developed with emergency responders rather than, give something during emergencies that emergency responders won't be able to understand or use. Next slide, please. And so what we're going to see here is an example of flow. And so you see there's terrain information, there's aerial imagery here, and you can kind of tell where things are. But next slide. Once you start adding topography information, you're going to start seeing that those rivers and that information come up more clearly. And so you can clearly see here the greens and the lighter colors. Well, the greens to be the lower terrain elevation, that's where rivers and water is collected. And then you have higher ground. Next slide, please. And so what our methods do is to extract the center lines of the rivers. And then based on that information, we can map the extent of the flood, extent and depth of the flooding as well. Next slide. That workflow that I showed you only include flow that is coming from rivers. So as rivers expand with rainfall, they expand over bank. But there's also a very important source of direct rainfall flooding. And so this is an approach that we have recently integrated as part of this PT 2050 project, in which we take the rain depressions, we flood them, we route the flows, and now we're able to create these compound flooding maps that include both the river and the rainfall events. And so you see here an example from Austin where the flood inundation is not only from the rivers going over bank, but also from rainfall directly. Next slide, please. And that's not where we stop, in terms that with this information, what we want to do is to integrate it with social vulnerability maps. And this is where I pass it over to Patrick again.
Yeah, so and this kind of speaks to the way previous projects are feeding into these flagships. We had developed a social vulnerability index for census block groups and census tracts as part of the Texas Metropolitan Observatory. And we're using that information. We're building a workflow to update that information every year when new data is released. But we're also utilizing that information to identify those vulnerable areas that are at risk of flooding. And what's really cool with some of this work that we've been able to do over the last semester plus is really identify those particular kind of vulnerable communities that are at an increased risk of flooding when you add in the fluvial and the pluvial. So it's not just looking at river and creek flooding, but when we start to take into account the nuisance and topography, depressions in neighborhoods, and all of a sudden you see these additional vulnerable communities that previously weren't in these areas of high exposure, now in areas of high exposure. And so this combination of fluvial, pluvial, soon adding in a transportation layer, and then also the social vulnerability creates these maps that decision makers, we can use both on the front end to help prepare and to plan and to mitigate, but emergency responders can also utilize to think about where to prioritize kind of rescues in response. I'm going to pass it over to Harry and Christine.
Thanks, Patrick. So if you're from Austin, you may be familiar with this particular area. This is House Park at 12th and Shoal Creek. This is Memorial Day 2015, and it's a flood that's going on here. And what you don't see at the bottom of the screen where you see that sort of fence structure, there's a rescue happening right there at the time this photo was taken. And so punch it one time. Let's go one slide. So what happens in an emergency? Not quite that far. So thanks. What happens in an emergency is that you have an incident commander that rolls up on this particular scene, and they communicate what's going on verbally. So they're trying to tell the Emergency Operations Center the scope and extent of this flood or this disaster that they're working with, and who's impacted and how they might access it, and on and on. So that happens over the radio or it happens via phone. But in all my years in emergency response, I used to like to say that disasters only happen on nights, weekends, and holidays. So imagine you roll up on this and you're the incident commander and it's 2 a.m. and it's dark and it's raining. How do you communicate the scope and extent of that? And you're putting rescuers into it and you're trying to rescue people out of it. And so how could that be done? So if you'll punch it one time, bring up that next slide. Thanks. So what if you were able to, like ordering an Uber, drop a pin at your point, at your location on a map with a mobile device? And what if that flood footprint was then immediately accessible to you? And Christine's going to talk about how that could happen.
All right, so let's go to the next slide. I'm going to walk you through an incident, and this is kind of the real life world that we're trying to access and provide information to. So Paula and her crew are doing all of this very sophisticated science, and we're getting this amazing return, but how do we make it usable to the non-science world that can actually, that has to do something during, these troubling times, so to speak. So I'm going to walk you through an incident. So it's 2 o'clock in the morning, like Harry said, because that's when we get our large scale events for some unknown reason. So all of a sudden, these flood calls start coming in. Next slide. And so what happens is we go ahead and dispatch a unit. So a fire truck arrives on scene. We're about 5 minutes into the call. The next slide. They will send a firefighter from that unit out with their mobile device and drop a pin where they're at water's edge. And so now we're at 7 minutes into the call, pretty quick. Next slide. And all of a sudden, this map is returned. This polygon is returned. So again, it being night, even if it's during the day, you know, we always talk about it being at night, which is one of our biggest struggles. But even during the day, how do you describe it? Well, there's a lot of water. Well, it looks like it's across the road. And so this gives them, the firefighters and emergency responders, a true understanding of the scope of what we're dealing with. And not only is this map available in the unit or on their phones, it's also available at other locations, dispatch, that are making calls on, should I send units from the east or should I send them from the west? Because maybe they can't get across the road. So next slide. So from here, you are able to identify the homes impacted. Next slide. The population. Next slide. Flooded roads. And next slide. And then you're able to access all of this information again in the field and at the EOC. So this is kind of the real world, how the real world's going to use this data out of the scientific element, even realm, even though we need the science to create it. So we're trying to make it accessible and understandable and usable for them. Next slide.
Thank you, Harry. And all this work is happening, I mean, similar to what we heard with regenerative cities, utilizing this equity lens and utilizing this co-design, co-production perspective, where there's multiple points where we interact with stakeholders. Here, I'm going to hand it off to Leave, who's joining us from Southeast Texas.
Hi, can you hear me okay?
Yeah, all good.
All right, so I'm on the phone. I couldn't get in the otherwise. So here I am in Beaumont, Southeast Texas, and it just so happened that in 2017, Harvey occurred. And you might not know, but the most rainfall by far ever recorded anywhere in the United States is 10 miles from the Lamar campus, right here in beautiful Groves in Nederland, Texas, at over 60 inches. That's 5 feet of rain in a few days. Can you imagine what the flooding was like? Can you imagine what the pluvial flooding was like here? And then 2 years later, there's Tropical Storm Imelda. Most people don't care about it. But as far as the National Weather Service is concerned, it was probably the most intense 12-hour rainfall ever recorded in the United States. It shut down I-10 with people stranded on parts of I-10 for 24 hours and others. Neighborhoods were super flooded everywhere. And so this compound flooding, where it's not just the river, but it's also the urban flooding, is so critical for here. We consider this the new normal. And with it, UT came to us and said, yeah, you know, you're the hotspot of the country, and we are. And we formed this Southeast Texas Flood Coordination Study. It exploded. We started in the late fall 2019. It includes federal agencies, National Weather Service, USGS, Army Corps of Engineers, US DOT. It includes lots of state agencies, TDEM, TxDOT, et cetera, and then tons of local ones and an entire 8-county region here. What Paula and the other people don't know is that I'm right now sitting at the Southeast Texas Regional Planning Commission conference room because of what's going on and because of the collaboration that we have with UT and Planet Texas and with all these agencies and everyone around here, the Department of Homeland Security has just drafted a research agreement with our 8-county flood control district coordinated by Lamar. And they are giving us 125 flood sensors for distribution, hopefully most of them by the end of 2021 here in this area. We will be the most data-rich area in the country for pluvial and fluvial flooding when this is all done. It's an immense thing. It will be the largest deployment of anything like this in the country, and we're hoping that the modeling that the Planet Texas 2050 does can use this data to help us with our decision making. Is that fine, or am I done?
That was perfect, Lee. Thank you
That
so
was
much.
great, Liv. Thank you.
You know, and again, we're so fortunate to have all these great partners in these locations. And what's really cool about what they're doing in Southeast Texas is, as Lee mentioned, they've established a flood study coordination group. So there's this formal governance mechanism that is in place and is developing to help think about mitigating, managing, and responding to flood and flood risk and flood. Our other site in Southeast Austin has a whole collection of actors, governance actors, decision makers, community organizers, et cetera, engaged in the same process of figuring out how to mitigate flood risk and respond to flooding. But it's a less formalized, at this point in time, a less formalized approach. And so this creates a really interesting, almost natural experiment for us as we engage in understanding how governance networks, and let's say we're going to call it a layer of governance, interacts with these other network layers in the multiplex model. And so we're starting this out in Southeast Texas and Southeast Austin as our first two study sites. And then as Paula referenced, we'll be expanding to other places in Texas. And really with this thought that the participatory engagement, there are multiple points for this participatory engagement. And one of those places is sort of flood modeling exercises where we work with stakeholders. But there's also this deeper co-production, we're calling it a deep integration process that we're going to be engaging in. And so I know this little figure is not super intuitive, but you can see up above the flood multiplex flood modeling, which we've made significant progress over the last 6 to 8 months. And what we're going to launch this summer is some governance surveys. So we have IRB approval to kick this part of the research off. We'll be starting in Southeast Texas and Southeast Austin. And then from that process, we're going to use those surveys to understand the networks, but also use them as a stakeholder analysis tool. So we're going to apply kind of a network analysis techniques to understand how actors are connected and where those central actors are to identify gaps. We're then going to create, you know, the big picture here, as you'll see in the bottom, is a hazards hub, but that's going to start with this in-depth process, pulling in stakeholders that we've identified from the surveys, plus additional stakeholders, to go through this, I'm going to call it, again, a deep integration or a co-production process to set a research and a policy agenda. And so we think it's almost, one of our partners at the Harry Ransom Center is calling it slow research. How do we just step back and reflect on what are the nature of and the important questions that need to be asked in this hazard space? And at this point too, we're moving beyond just flood. We're really interested. We know that there are research practices, data layers, data tools that are applicable in the modeling we're doing with flooding that are also applicable for other hazards. And so this is going to be the phase where this research agenda is not solely about flooding, but it's going to incorporate other hazards that these locations and cities and rural regions more generally are dealing with. We are needing you. We need lots of knowledge. We need local knowledge. We need expert knowledge at lots of different phases from this kind of hazard continuum of preparedness, response, and recovery. And so we would love for you to be involved. I posted a link to this brief survey in the chat. And there's a couple of different ways, right? The hazard, starting in the fall, we're going to have these broader hazard hub meetings. It can be a pretty passive engagement. You can sign up for updates from our project, again, pretty passive engagement. Be notified and participate in these local flood exercises. So this is where some of the participatory mapping is going to happen. But if you're also interested in this more deeper and sustained engagement, please let us know. We're looking for a mix of kind of the local implementers, decision makers, community organizers. We're hoping to bring in some folks from the state policymaking level, as well as researchers. So please fill out that form and let us know if you're interested and how you'd like to engage. And that's all we have. Please don't hesitate. There's a typo in my email address, but another great way to connect with us is sending us an email.